Hiç unutmasan şimdi slide'a başla. Evet, slide'dasın zaten.
Okay, I think we're live. Hello and welcome to the fourth installment of the CodeRunner series, fourth part. Today we're going to talk about serverless on AWS, how to use these services with using .NET tooling, of course. And I'm here with Emrah Uslu. Hi.
Hello everyone, my name is Emrah Uslu, I'm the DX lead of PeakUp, and we're going to talk serverless architecture with Fatih.
Yeah.
I'm so happy with you today.
So let's jump right in.
Yeah.
Let me switch the yep. So and I'm gonna start the So today's agenda is first of all, we're going to talk about what is serverless, how we end up here today, and we're going to briefly talk about Lambda, and after that, we're going to look at what it offers to us, what benefits of the Lambda, and after that, we're gonna look at how to use these services with .NET tooling, Visual Studio. We're gonna create a function and publish that, and use the .NET Core Web API if we have time at last in our demo. And that's about it.
Yeah, today we have more than 3 demos.
Yeah.
So it will be great session.
Yeah, we're gonna have to skip maybe some of the slides to give time to demo. But if we
have time,
we're gonna look at the .NET Core Web API, ASP.NET Core Web API demo, if you have time.
Okay.
Yes. So, serverless computing. What is serverless? We have to talk about this at first. What can we say about that?
Serverless computing serverless architecture is a way to build and run application without have to manage any infrastructure.
Yeah.
So you don't see any infrastructure, any server, but of course these services run on a server.
Yeah.
But we don't have to manage them.
Yeah. It basically boils down to First, we have to talk about the history of the serverless, I guess.
Yeah.
How we ended up here. First, there was VMs, virtual machines. At that time, the virtualization world was becoming a thing, I guess. And because our applications were suffering from the compatibility type of things, one application requires a .NET framework 4.1, other one requires a 4.2. That creates a conflict. Because of that, our applications cannot be in the same VM, for example. Containers resolve that because every application lives in a different state, different compartments. That solved some of the problems for us. But there's more. Our applications, we require them to run exactly when we need. So that created us a serverless phase. So these are the services you can use. You can use your VMs in EC2. Container service for in Amazon is EC8, and serverless is AWS Lambda. So let's go fast.
Yeah.
Lambda is you can call it via AWS SDKs or using what called triggers. In AWS offers API gateway. You can use it to call via HTTP calls, and or you can use directly in the AWS and call as a service. And you only pay for the compute time you consume. So
yeah. By the way, let me add a note. We pay only for the compute time we consume.
Yeah,
it's
yeah.
a great thing. There's a free tier. And in this free tier, we have 1 million free requests.
Yeah.
The first 1 million requests is free in AWS Lambda. And it's a great opportunity to supply your code which AWS with a language which AWS supports. For example, C#, Python, Go, Node.js, etc.
For the Lambda's programming model, as we said before, you can bring your own code. It's basically a runtime service for you. You can run your Node.js applications, Java applications, C# applications, Python applications. It offers a simple resource model. You basically select a RAM, how much you require your RAM, and it will automatically allocate the CPU and network for that specific application. You just select the RAM specification. And in AWS Lambda, the AWS SDK comes in it. It acts like a web server. You can actually reach out to processes running behind it, basically Linux container. So you can do that type of things. And it's stateless. So when you start to code, it goes from blank to actually you have your roles to access the services in AWS Lambda, but it doesn't know anything other than that. So it's stateless. So how you run it is you can call it via AWS SDK, or it automatically runs when something happens. That this is called pull model. Push model is the request one when you request it to run actually, and you can trigger it using S3, DynamoDB. Maybe you can say if some file added to the S3 bucket, run. So you can say things like that. So when it's on Lambda, there's no servers to manage. As we said before, that is great. And it automatically scales because every time you run something, it creates another Lambda instance to run, actually. So you don't have to manage any type of scaling things. And you never pay for the idle time. So when you're not using that Lambda, you're not paying for it.
I can add one note for here. If your functions run more than hours, so we shouldn't go with Lambda.
Yeah, maybe not use Lambda. Use beanstalk or something else.
Yeah, use beanstalk or use EC2. And when your function deployment package, more than 50 megabytes, so you maybe plan to put this functions into multiple packages and then separate them and then run functions too.
Yeah, if you have 50 megabytes of Lambda function, maybe you're not doing the right thing. So,
so go with the EC2 or the install maybe.
Yeah.
Again, okay.
Monitoring, debugging things, you can log in your AWS Lambda. There's a context for that. It comes in it, and you can log stuff. You can see the requests, errors, and whatnot. So, in the how we start to do Lambda projects is you install the AWS SDKs and toolkit, as we talked in our previous sessions. If you didn't install that, please watch the Work 1 or Work 2. We covered that before. And when you create an application project, there's a AWS Lambda option, and you can create a project, select a template, and publish that right away and start fast. There's this is the sample code for the function, and it creates S3 client, whatnot. We're gonna take a look at these in our demos. So I'm just skipping fast. This is the upload Lambda function wizard. You give it a function name and upload, and configure if you didn't have any function before. And this is the after upload completed. You can see the functions state. You can invoke it through here, and etc. Input and output. We have to talk about this because this is really important. Function only supports a JSON input and output. Maybe actually you can use string. It's basically any kind of content, but other than that, you have to use JSON input and output. So everything is JSON here. And you have to use a specific version for the C# side, JSON version 9.0.1. It only supports that, so it's really important.
It's a library that you can download from the NuGet.
Yeah. JSON.NET. Maybe you are familiar with it.
Yeah.
And Newton-Salt JSON is the namespace for that. So we see the serializing input for the request for the Lambda. This code creates a dictionary, adds keys and values in it, and makes that JSON to call the Lambda actually. And when you receive that JSON, you can parse it using as we said before, just Newton-Salt JSON, and use that object in that function. And this is a sample function handler, and this one's you can log in your functions. As I said before, there's a context for that. In that context, there is an object called logger, and you can log into that. That actually creates a log in CloudWatch. So you can go and look at the logs in the CloudWatch.
CloudWatch is another service in AWS.
It actually, in every service you use, you can log, and actually some of them automatically logs some things for it, and you can go and
monitor it.
You monitor it in the CloudWatch. So
good, very nice.
And there's a screenshot in the function side. You can see the monitoring, and that page is actually shows us the logs. So use cases.
Yeah.
Are we going so fast or?
I think we're good.
Okay. For the use cases, maybe as we said before, you can actually call your functions through AWS SDK or using API gateway to request it through HTTP requests. That actually opens up a lot of ways to use it, but there's also other type of use cases for it. So you can use it as an event source. As we said before, when there's something happens in the S3, or you can actually use the database for Amazon offers, Amazon DynamoDB. When records is created, you can trigger it too. Kinesis is the IoT backend for the IoT service the AWS provides us. You can basically do event-based triggering. There's also a SNS support for it. So when you maybe pass a notification and the function runs.
Yeah, one of my favorite use cases is scheduled events.
Yeah.
So if we run a function on a regular basis, for example, we have a code to summarize and calculate some overview of our data. We can set up this function and run every day at 10 o'clock.
Basically a cron job, yeah.
Yeah, it's a cron job. It's a very simple use of and very useful use of a function.
Yeah, yeah. And so let's go over these use cases using images. This use case is real-time file processing. Maybe you take a photograph and put it in an S3, and when that happens, run and scale that image and whatnot. Real-time stream processing, as we said before, Kinesis is the IoT.
Yeah, it's a complex event processing tool of AWS. And when we have a stream and we have a calculation or we have a job to do, we can set up a function to trigger,
analyze the data,
analyze it, and then put the data in a database like DynamoDB.
Yeah. So you can use it for your ETL processes. When DynamoDB item created, when it's something inserted,
you transfer your data and then load it to another service like Redshift.
Yeah. As we said before, to backends. Maybe you have a tractor that uses some sensors, and that way you can trigger it and maybe place a order. Yeah,
it's a good use of IoT use case here. We may have some limits, minimum limits and maximum limits. And we have some data coming from our sensors, and we can check our sensor data is between the minimum or our minimum maximum data. So if our sensor data exceeds the limits, we can create a push notification in our function. So it's a very good use of function.
Yeah. Maybe something broke and you're not receiving any data from it.
Yeah.
You can maybe order a replacement for that.
It's a basic use of anomaly detection.
Yeah. And for our mobile backends, and as we said before, there's an API gateway event source for it. You can trigger your Lambdas with it and push a notification on whatnot. And for the web application, it's basically I think it's a really weird or really great way to use the lambdas. You can actually, we have a demo for it. As we said before, if there's time, we're gonna do that. You can publish your .NET Core web application to S3 and Lambda, and you have serverless web application basically.
It was great. It's great.
Yeah, this is the use case for this image is the use case for that. And we're gonna go ahead and demo it.
Yeah.
So let's jump right in. Okay, we're gonna have to create a project first. Wow. And as we said before, AWS Lambda option is here. We're gonna create a Lambda project, AWS Lambda project. I'm gonna name it CODERUNNER.work4 right now, and call it custom function, and make the solution name work4 alone. It's gonna ask us what kind of function you want. We're gonna create an active function now, and let's click finish. It actually creates us a project type for the AWS Lambda. It contains the configurations for the AWS function. Let's look. This is the function now, and when we look at the code, it's actually simple as that. It receives an input and outputs a uppercase output. So it's really basic. And let's publish it. I'm not going to change anything. Let's have a look first. I'm going to name it custom function. It's my function's name. Runtime is the 2.1, framework is the 2.1. Let's go. There is a profile to use up here. Default one is used now. That's important actually. If your role doesn't have any access for these type of actions, it will fail. It's important. I can use the AWS Lambda full access. It's actually can access the S3, DynamoDB, CloudWatch, etc. I'm gonna select that. And for the memory, there's 256 megabytes selected. You can configure that. And I'm gonna hit upload. It's gonna first build actually and run the .NET publish code, and after that publish action done, it's gonna upload the output in the AWS Lambda.
It uses .NET Core. Is it possible to use traditional .NET framework?
Actually, no. You have to use .NET Core.
Okay. It's good.
So our function is up and running. Let's have a look in the AWS console. I'm gonna go ahead and go to Lambda. My function is here. I can look at it. So, as we said before, custom function is here. This is the possible outputs, and we don't have any input yet. That actually event source is empty right now, but we can test it through here. I'm gonna hit test, and so I'm gonna create a new test event. I'm gonna say maybe no. Let me. Please let me. Wow. My event name is test, maybe. Okay. Test, maybe say hello world. And create that test and test it bit. Execution is done. As you can see, the output is hello world in uppercase. So our function is running smoothly. So now we're gonna run it through API gateway. So we can call it like a normal API. I have to add API gateway for that, and I have to actually change my code to run it properly. But first, we're gonna take a look at why we have to do that. When I add the API gateway, I have to configure it first. I'm gonna create a new API for it. Security is open, so I can call it easily and provide nothing for the security or API key, whatnot. I just have to call it publicly. And I'm gonna name it PeakUp sample API, maybe. And deployment stage is the default. I'm gonna leave it that, and create. Click the add button and click save button. This is gonna create a API gateway for me, and actually adds an endpoint for the AWS Lambda, and uses the proxy way. So this is the API endpoint. As you can see, it screams at me internal server error, because we're gonna see why. I'm gonna open Postman and post the other sample hello world, and I'm gonna receive the same error this time too. First we have to see that. I'm gonna close that, don't save it, and create a new one. I'm gonna post, and as a body, I'm gonna use JSON and input this same input. I'm gonna send it, and I receive an internal server. Because API gateway handles the input and output differently, it actually requires us to have inputs and outputs in some type of construction, some type of thing. Because of that, we have to actually reference an nugget package and use specific classes for the input and output. This applies to other event sources, because event sources sends data in some way, and the function have to have that input and output format to trigger it. So I'm going to go ahead and manage my nugget packages and browse for the Amazon Lambda that you can see the packages here. For the API gateway, I have to reference the API gateway events. Let me reference it. So it's done. As I said before, for the input, we have to use API gateway, proxy, request.
Maybe it's better to zoom in our code.
So, okay. Right. can see right now. And at the using, for the response, we have to use API gateway proxy response. This class is actually helper classes. You can always create your classes for the input and output to use, but it's easier to use these classes. It's basically a status code for the response, handlers, body. API gateway proxy requires the response in that format. So because of that, we are receiving the internal server because API gateway couldn't parse the response. And we're gonna return status code 200. That means okay. And for the body, I'm gonna do the same thing actually. For the input, there's a body and headers and whatnot. Body is the thing we are sending, and I'm gonna uppercase that body. And I'm gonna publish it like before. Next. And upload. I'm actually uploading the to the same function. Oops. Okay. It does that sometime. I have to add the uninstall and install again because I forgot the build it and publish actually dereferences the recent references somehow. I don't know. And I'm gonna build it. Okay. And I'm going to publish again. Next. Wait. Okay, upload.
Okay, I have a question. When do I have to use API gateway for my functions? For example, if I use my function as a cron job scheduled for scheduled things, should I use?
Yeah, you don't have to use the API gateway. If you require it to run through HTTP requests, basically you wanted the Lambda to act like an API. API gateway actually creates us a way to reach that Lambda. It gives us a URL to call for us.
So if I need to communicate internally in AWS services, maybe I don't have to use API gateway. But if I want to open my function publicly outside, so I
or
need
as
to,
API with access key or whatnot, you can use the API gateway.
Good.
API gateway also offers some of the other type of things. Maybe, for example, you can authorize using access keys and configure it within the API gateway. And other than that, you can give a quota in for specific API key, and maybe it can run 500 times a month. But maybe you can do these type of things in the API gateway. And my function is completed. When I try to test this here, it will not work because this time it requires a specific input and specific output, specific output. Because of that, I'm gonna call it via API gateway and send the same input. And here I go. The same output when I tested before. So API gateway is done. The other demo is triggering it via S3 events. maybe if I put something in my S3 bucket, and this function will be triggered with that. First we have to actually create a S3 bucket. So I'm gonna go and do that. Go to S3.
By the way, we talked about S3 in our previous session.
Object storage.
If you wanna go deeper with S3, you can watch our previous session.
So I'm gonna create a bucket here and call it PeakUp bucket. It's in US East Ohio. Okay. Please remember to put your resources together in one zone if you want to access them via roles or whatnot for the performance issues, etc. So my bucket is created, and this bucket is empty right now. I'm gonna configure my function to trigger when something happens in S3 bucket, in my S3 buckets. So I hit the X and it's going to delete the API gateway bound, and I'm gonna select S3. It tells me the configuration is required. I'm gonna go ahead and select the PeakUp bucket here. You can change the event type when the object created, this will run, but you can also say when something removed, run this. You can do these type of things. And for the maybe you don't want to trigger it every time something happens in the whole bucket, but you actually require a specific bucket container to trigger it, and you can always use a prefix for it. Input something like logs maybe, and the function will trigger only if there is a new item in the logs container. So it's a good way to separate the functions and use the same S3 bucket for it. And for suffixes, maybe you want to run this for specific file types. You can always use the suffix to manage it. So I'm going to go ahead and click Add and click Save. This will not work too because the input and output is changed now because we're not using API gateway anymore. So we have to change the input and output event types for it. We're going to go ahead and fetch the AWS Lambda S3 events package. Where is it? Maybe. Yeah, S3 events. This contains the input type and output type for those specific events, and we can use it in our function. So class name is the S3 events. We don't have any output now because we don't want to. And we're gonna log what comes in the S3 event. We're gonna go ahead and look at the records. Records is the thing, how to say, S3 event is not only triggers when one specific object is created. Maybe there is 5 files uploaded at the same time. Because of that, this S3 event input is contains the all affected records or files keys in it. So we're gonna call it record, and as we mentioned before, we're gonna use the logger and go look at the CloudWatch to see our logs. Context.logger it's called, and there's a log method for it. We're gonna log the bucket name and the maybe keys name, and let's call it records. There's a object called S3. In that, there's an class called bucket. In that bucket, it contains its name. So we're gonna call it bucket. And for the key, I'm gonna tell it record S3. It contains also the object, and in that object there's a thing called key. That way I have the bucket's name and the affected file's name uploaded, or maybe something else. So I'm gonna upload that function. No, at first I'm gonna build that. I don't want to re-reference every time that happens. So I'm going to click next and upload. I configured the input before, S3 input, as we've seen. Okay. Now, let me open the monitoring site and view logs in the CloudWatch. This is the CloudWatch screen, and I can see the logs for that function. So this gives me the other we called before function, and this is the start of that request, end of that request. I can see how much it took to run, etc. And the duration is that, and what we used in that specific time. You can see this type of logs in here, and this is the screen, how much implicated, how much time it took, etc. And I'm actually going to put something in the S3 bucket. I'm going to hit the upload button. I'm going to add files, maybe upload our slides image, and hit next, 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 upload. Our file is uploaded. The file is here. I'm going to go ahead and refresh the CloudWatch to see my logs, because I logged the bucket's name and the file's name in that. And we can see here it is. The request started here. This is the log I wrote before. Bucket name is the PeakUp bucket, and the key is the this is the file's name, and the job is ended here, and this is the report. So it's a great way to watch your applications, and you can also see the errors in the CloudWatch. If that happens, you can get here and see what goes on. I think we have time for the
other demo.
Yeah.
Yeah, we have 13 minutes more.
So we're gonna create a AWS application for using ASP.NET Core. That application is actually we run on Lambda, and for the other files, maybe your CSS files, JavaScript files, HTMLs, etc. These files will be reside in the S3. So it actually uses S3 and Lambda to host your application. This is actually a full-fledged ASP.NET Core application. Because of that, it's really great.
So we don't use EC2, we don't use vInstall to host our web application. It's a fully serverless architecture application.
Yes.
It's nice.
So we're gonna go ahead and click our solution, add new project, and in that you can see serverless application. The Lambda project is the one function to call. Serverless application is actually it creates I think two functions. First one is the for applications create how to say. First one is the root one, and the second one uses something called proxy to actually route your error request to that function. So it actually uses two functions to manage that. I'm going to call it CodeRunner War2. War 4 now. And call it custom application. Maybe call it custom ASP.NET Core application. And with that, okay, it actually offers me a template for the ASP.NET Core web app, and I'm gonna use that.
Yeah, that template uses the Razor pages, right?
Yes, uses the Razor pages. Actually, you can always reference the required package for doing these type of things, but this template actually gives us a Razor template, Razor pages template, and applies the necessary changes in that project to actually run on AWS Lambda. And we can see the project architecture, and this is the index page. Actually, let's run it first. So I'm gonna go ahead and run the project first. Okay. I'm now waiting. Oh. Why? Maybe not. So let's go ahead and make some change. Hello from PeakUp. And I'm going to publish this application to AWS Lambda. In this wizard, it asks me something called stack name. I'm going to explain that after we publish it. But first, I'm going to name it PeakUp stack. And it uses the same bucket we created before. Uses the release configuration, .NET Firm, .NET Core app 2.1, uses it as a framework. And it's going to publish this application to the AWS Lambda and S3. And it uses something called cloud formation to do that. That's why it asks us the stack name. Stack is actually you specify what kind of resources to have to be created for that whole application to run. It creates us that to function, manages the roles for us, creates an API gateway, and hooks up the functions to be created. So we have I think we had.
There's a validation error.
So. Member must have length. Oh, the project name is the problem.
Yeah, it requires less than 128 characters
for the handler.
Our project name is
too long.
Too long. Yeah.
We're gonna delete the stack actually and do the whole thing from the start. Let that delete. I'm gonna remove the project and delete the
delete it from the directory too.
Yeah. And create again. Let's have the serverless application CODERUNNER var4 and a custom application. Let's keep it that way. And ASP.NET Core Web App, finish. Let's make that change again in the pages index file and call it h2 hello from PeakUp. And let's build that first. And
do you think can we validate the stack name if it is more than 428 characters now?
The result doesn't do that, but yeah, it's weird actually. I don't have a stack now. Pick up sample stack. Okay, everything looks fine. It's gonna do the publish again. It restored the packages. Builds now. Yep. Zips the publish directory and uploads the created file, zip file to the S3 and the template for the cloud formation tools actually. We can see the template here, and it's actually a recipe for the cloud formation. It tells us what resources we use, ASP.NET Core function. It creates us this and hooks up the slash and slash proxy endpoints for the API gateway, and outputs a API URL for us to go ahead and see our application running. And create is actually completed.
Yeah, good.
Yay! And this is the output. When I click it, we can see the application running successfully. And this is the demo for the AWS Lambda and serverless applications. We covered what is serverless. We covered the AWS Lambda, a serverless service for the AWS provides for us, and we see the creating a function, uploading that function to AWS, running it, hooking up the API gateway and S3 to that, and we look at the S3's trigger if we upload any kind of file to that. And at last, we saw the fully fledged ASP.NET Core web application running on just only using the S3 and the AWS Lambda. This application only runs if you request that. So it's basically magic.
Yeah, it's very nice.
So that wraps us. Thank you for. Let's switch the slides again. Thanks for the watching us, and next week.
Yeah, see you next week.
See you next week.
Bye bye.
Bye.